Welcome to our lectures on the advanced power electronics and control. Today we shall discuss about the remaining part of the chopper, thereafter we shall switch over to the isolated DC to DC converter. So, let us come to the point where we have left, that is basically class E chopper. It is actually all the mode of operations for it is possible. So, first quadrant mostly CH1 and CH2 is on, while it is actually current flowing in this directions, and CH2 and DS2 conducts. So, when it is actually regenerative braking, then just this will have a interchange, this nomenclature will have a interchange, that is CH2 and D4 will conduct. So, CH2 and D4 will conduct and you will get a regenerative braking, and since the voltage is positive and you essentially get a forward voltage mode and motor will be actually operating in the same directions, and it is the motoring and the regenerative braking. Same way, if you wish to operate D3 conducts, D2 D3 conducts, and then for the regenerative mode, then for this actually CH4 and D2 conducts, then essentially your voltage will be reversed and you will be operating in actually reverse motoring mode, because your current is positive, but your voltage is negative, and it is just opposite to it where you have a regenerative braking, and it is possible to have a regenerative braking in also in the reverse direction. So, you will find CH2 CH3 will conduct, this will be conducting. So, current will have a change in directions, and CH2 and D4 will conduct. So, here please note that in a this mode and this mode are essentially, you see that what are the changes. Here you can point it out very easily, what are the things it will conduct. So, here if current flows this direction, of course, you have to operate CH1 and CH4. So, this will be operating, and since current in unidirectional, so then in next case of course CH4 and D2 will conduct for off time, and current will be always positive. And now in this zone you can find that CH2 and CH3 on same way. So, this will be on and CH2 and D4 will conduct. Here CH4 and D2, here it is CH2 and D4, just actually the mirror image of this operation. Same way here and here you will find that basically CH4 D2 conducts, here you will find that CH2 D4 conducts, and also the diode will have an interchange, because D1 and D4 will conduct in this operation because voltage is positive, and in this case since voltage is negative, D2 D3 will conduct. But here this will first on will be when T on will be operated by CH2 and D4, but first D2 and D3 will be conduct in reverse mode, thereafter followed by CH4 and D2. So, this is the 4 quadrant operation of the chopper. So, gradually let us brief up what we have discussed. Class E chopper is a 4 quadrant chopper, CH1 and CH4 are on, then output current flows in the positive direction through CH1 and CH4. So, the output voltage is positive and equal to V0, and it gives a first quadrant motoring operation. When CH1 and CH4 are off, the output current I0 flows to the same direction through the load current D2 and D3 due to the inductive load and current to be assumed to be the continuous. So, the output voltage becomes negative, hence chopper operates in the 4th quadrant. When CH2 and CH3 are triggered thereafter, then the load current I0 flows in opposite direction and the output voltage also become negative and motor will start operating in a reverse direction. So, both V0 and I0 are negative, chopper operate in third quadrant. Thereafter, when CH2 and CH3 are off and load current flows in the same direction as before through the load and D1 and D4 due to the inductive loading and high constant current, high value of the current because of the maybe the high torque, and we assume that current to be continuous, not necessarily constant. So, output voltage become V0 and so it is basically the fourth quadrant operation. So, since V0 is positive and I0 is negative, again chopper will come to the second quadrant. Now, let us come to the new topic that is very important from our present perspectives. This is again a DC to DC converter, and this DC to DC converter require there is a little bit change of this DC to DC converter what we have discussed it. So, we all are aware of this term SMPS, switch mode power supply, and switch mode power supply, this name is familiar with the, our history goes with the desktop. So, we say that switch mode power supply is operating or it is as a faulty or whatever maybe SMPS. So, there is a actually a point of using the SMPS. SMPS essentially are synonymously used as isolated DC to DC converter. So, why isolation? We have to flow power from input to the output and the load may be very sensitive like your desktop, like your laptop, like your mobile, and you want that disturbances or the surges or any other disturbances of input side should not cripple or damage your highly sensitive load, or you got a load side protections. And for this reason what you want is, in between there will be a flux linkage on galvanic isolation, and due to that you get a more controlled power, more purified power, more safe power at the output, and that is one of the best advantage of SMPS. And SMPS, this magnetics comes into the pictures are not bulky because it uses the high frequency and the size of the core is reduced and you may have a compact packaging also, which you can refer, you can refer to this actually charger of a iPhone, it is quite compact. So, it uses the same kind of circuit. So, it is an electric power that incorporates switching regulator to convert the electrical to convert electric power with high efficiency. We can convert power and also with a huge change in a input and the output variation. Let us say you are using a mobile charger and you have taken to the countries where actually supply voltage is 110 volt instead of 220 volt in India. So, you should be able to use that. So, there SMPS finds its application, like your laptop which you are using in India, it is not like that you will not be able to use the same laptop charger in USA, because please understand that most of the laptops are now manufactured in Taiwan and it is been actually totally exported to the various countries. So, this has a compatibility is available with your laptop charger. Like linear power supply, SMPS to convert available unregulated DC to AC input voltage to a regulated DC voltage. Most of the cases you plug in, so you get a rectification. So, for this reason you got a unregulated DC stage, and your voltage may actually sag, swell, surge, anything can happen, but you get a regulated DC at your output voltage. The SMPS input supply is drawn from the AC supply, then it is rectified and filtered by the capacitor, and you have seen the challenges. Nowadays actually modern way of rectification is the PWM rectification, which we have already discussed. The unregulated DC supply across the capacitor then pass through the high frequency DC to DC converter, because in between you have a high frequency magnetics. High frequency transformer used in SMPS is small in size, since you know that actually V equal to B A N F, there will be a constant. Generally if it is sinusoidal it will be 4.44. So, if you can increase the frequency, so the same voltage decaying, so this value essentially it is a B and the area, B is the flux density and area of the A is the area of the core. So, B will be depending on the material, you can choose a different material, and thus value of the A will decrease. The high frequency transformer used in SMPS is much smaller in size due to that and weight compared to the low frequencies actually transformer used in linear power supply. Generally we have most of you have done basically used it for your BTP project, or you will be using it. So, we use actually IC Regulator 7805 that gives you regulated 5 volt, and essentially what you do, your solution is quite bulky. What you do essentially, you actually rectify, you use a very bulky transformer of 0 to 12 plus minus 12 actually 220 volt to 12 volt or 9 volt. From there actually you get it rectified by a bridge rectifier, that you put a filter and then you put this 7805, that is series IC regulator. So, that is a way of doing it, and if you have used it, you can imagine that how actually bulky is your solution, and instead of that actually same thing has been done by your laptop, your mobile charger, and how compact it is. So, high frequency transformer, so the switch in SMPS is turn on and turn off at high frequency, and that is a challenge, you know. So, for this reason what happened, we generally preferred MOSFET as a suitable design, and most of your below 100 kilowatt, these are all MOSFETs, sorry, below 100 watts, these are all MOSFETs. During the on time the switch is actually in a saturation mode, so that you have a low conduction losses or the negligible voltage drop across the collector and the emitter, or the in case of the IGBT, or the drain and source in case of the MOSFETs. So, if you require to go a little bit of higher power rating, then you require to use the IGBT. The off time of the switch is in cut-off mode and with a negligible current through the collectors and emitters or drain and source, and thus turn off losses is basically when it is switch off. So, there is almost open circuit condition prevails, and when it is switch on, short circuit condition prevails. The voltage regulation in SMPS is achieved by varying the ratio of T on and T off. Same way we have seen that buck boost and buck boost converter and Chook converter. So, some SMPS instead of the using high frequency transformer, use high frequency chopper is used for the higher power rating. Generally it uses GTO, but of course you have to be operated around sub kilohertz frequency. So, maximum you can go as high as actually 1 kilohertz, and your power rating can be much higher, you know, around 100 kilowatt. So, let us come to the linear IC regulator. You have most of our have used is actually I was naming 7805, 7812, that is 12 volt regulated IC. And mostly where actually input and output are very close, we will be using this kind of ICs. So, let us see the principal operation of this IC regulator. Mostly these are quite actually, these are used for the gate driver circuits of this converters. The linear regulator system is used to maintain the steady voltage. This fact is a desirable resistors continuously adjust and the voltage divider network to maintain the constant voltage. But you have to ensure that this input and the output voltage are quite close to each other to have high efficiency. The difference between the input voltage and the regulated voltage is dissipated as a heat. So, if it is a huge difference, the huge chunk of the energy is being dissipated as a heat. So, that will be inefficient solution. Moreover, actually you will provide a sink to the actually dissipate the heat. So, there are two type of regulator, one is shunt regulator, another is series regulator. So, shunt regulator is essentially, you can simplify like this, there is a, you have studied into analog electronics. So, that is you got a current control resistance and this is a zener, you will have a sharp cutoff voltage and you will get a regulated voltage here. So, shunt regulator provides a path for the supply of the voltage, but there will be a constant power dissipation across this R1. Path supply the voltage to the ground through the variable resistance. So, the current through the shunt regulator instead of the flowing through the load uselessly flow to the ground. So, it is less efficient than the series regulator and it can be used for the low power circuit where wastage of the current is too small and generally it is used for the gate driver or actually or biasing of the transistors in signal level. Now, let us come to the second point, that is this is a series IC regulator. See that what happened, the series IC regulator actually will have a feedback anyway. There are more common and efficient solutions, actually what I was talking little bit ago, 7805, 080, 012, these are all series regulators. It works by providing a path from supply voltage to the load through the variable resistance. Power dissipated by regulating the device equal to the product of the power supply output current and the voltage drop of the regulating devices. So, actually if you this variable resistance, then voltage will change. If voltage is changed, then more current will flow and then actually we have to regulate this voltage. We will come the next circuit and will see that how does it operate, and it is operated by a feedback. So, it is so for the better efficiency and reduce the stress across the devices, regulator should be designed to minimize the voltage drop. So, we can find this actually IC regulator everywhere for the low power applications. In case of the automation, like we use mostly a we use basically a processor or this actually microcontroller, Arduino or the simplest microcontroller you might be using for your BTP projects and all. So, that can be used for the automation. So, you can use it for this medical operations. So, you require a very regulated power supply and there actually you do not want that actually the switching. Switching will actually gives you the EMI EMC and that is not actually possible to use. So, and that will be hazardous to the patient. So, in that kind of applications we are monitoring any voltage or current, voltage or pulse speed or something or amplifying. So, there kind of these applications actually this IC regulator is preferred. Motorcycle, e-bikes and the small electric vehicles. So, there also where voltage difference is not very large because you have a 12 volt supply and also you have a almost 12 volt consumption. So, there you can use for the data processing, electromobility and other drives, and you can use for the lighting and the smart grid technology. Now, let us come to the SMPS. So, you can use those things, but if this actually mostly you use those things for because you actually verify the concept with the prototype. But in actual practical application where power rating become high, then we have to replace this IC regulator by SMPS. One of the advantage of the SMPS it will have a lower weight with the same power rating and smaller in size, higher in efficiency, reduce cost and lower power dissipations and high power rating. It is possible to go for the SMPS with a megawatt level, because you may have an offshore wind power plant and you want to transmit that power to the HVDC link, and that is also possible by a DC to DC converter. Wide AC input variation range, which I was talking, same laptop charger can be used in India and USA. But disadvantage is that design is a challenge. So, there is a potential for the future engineer like you actually, and there is a huge scope of and a huge job market for it. So, essentially this is a block diagram of the SMPS. You got an inputs, it may be actually regulated, unregulated DC or AC. In case of if you are using a solar panel kind of thing, then it is unregulated DC, because its input voltage will change, input voltage and current will change according to the irradiation and the temperature. And this is a mains input, then there will be a rectifier. So, if it is basically AC input, then you have a inverter chopper, we will see to it actually how does it work. So, and it will be high frequency. Thereafter, you have a transformer, that is basically high frequency transformer, then you have a filters to filter out the ripples and makes it DC, and this filter and before that there will be a rectifier, and generally we use a different kind of rectification, that is called a synchronous rectification, because RD on of the MOSFET is quite low instead of the diode drop. So, we can go for the lower losses by switching also, and there is a DC output, and you will be controlling the switching in such a way that you can get a regulated output voltage in this point. And there if there is a step down and step up operation, you can play with the transformer's trans ratio. So, that is one of the biggest advantage of it. So, if you are actually bucking a voltage like 20 times, 30 times, then actually one of the disadvantage of the continuous of the non-isolated DC to DC converter is that duty cycle will be quite low. So, actually if you are bucking to 300 to 5 volt, that is actually kind of bucking you will get in case of your laptop mobile charger, because if you are feeding to the actually through a diode based rectifier, the peak voltage of the DC is around 300 volt, and since it takes a very negligible amount of the current, so actually you get almost a 300 volt, and you are actually getting a regulated 5 volt. So, if you use a non-isolated DC to DC converter, so actually K, actually what essentially you will get is basically 5 by 300, and you will be forced to operate in a discontinuous conduction mode. And what we have studied all the analysis, and this ratio is also be flawed then, because we have derived it for the continuous conduction mode. But here you got an advantage here. So, you can also play with the trans ratio. You can actually buck it by this transformer here, and also you can have a 220 volt by 110 volt, and you need not have to go USA, because if you are charging your mobile also in the train, that also has a 110 volt supply. So, it is a quite important aspect, and its control is quite challenging, and thus people like you has an advantage to work on it. The rectifier stage SMPS is used when input is AC supply, but SMPS with the DC supply does not require a rectifier stage. So, you can have a huge variation of your input. Rectifier stage provides a regulated DC which further process to the filter. Inverter stage converts DC to AC by running through it the power oscillators with a small output transformer frequency ranging from 10 to 100 kilohertz, and the power rating is actually just reverse. So, it can go to 1 kilohertz to 1 kilowatt to 100 watt. For isolation, the output from the input, one frequency of transformer is used which can step up or step down voltage according to the requirement. So, as the output requirement is DC, the voltage of the output transformer is again passed through the rectifier circuits and filter, and it gives you the ripple, was almost a ripple free DC. Feedback circuit compares the output voltage, there will be outer, we have discussed that thing in the buck and boost converter analysis. Feedback circuits compares the output voltage with the reference voltage and produces the necessary pulse signals for the switching used for the control of the converter. Now, this we have named 5 topologies of the isolated DC to DC converter, and these are essentially ascending order of the power. So, flyback can be operated maximum around 250 watt. It is a challenge to have a flyback to be designed more than 250 watt. So, thereafter till around 2 kilowatt. So, all your laptop charger, SMPS of your desktop, your mobile charger are essentially falls into this category of flyback converter. Now, forward converter, it will have a ranges of around 2 kilowatt, and which might be using mostly of your power supply, DC power supply in your labs, or you have a little high current requirement like LED drivers, or you have a for the lightings and all those issues, you may use the forward converter. And if you actually of course, getting the forward converter over 2 kilowatt is also challenge, because till now you can use MOSFETs. Now we require, and basically switching frequency can go as high as 100 kilohertz for hard switching, and there is also concept called soft switching, that is ZVS and 0 voltage and 0 current switching. Then you can go as high as 500 kilohertz maybe, depending on this parameters of the MOSFETs. Otherwise, actually we restricted to the 100 kilohertz, because actually this switching losses will predominate, and so we have to choose higher rating MOSFETs here, and this can be maximum we can operate in a range of the 20 kilohertz. We shall see that why it has been restricted. And there is a push pull converter, so you can go as high as 5 kilowatt, and you can extend that range to the 10 kilowatt, and thus you require to use IGBTs, and maximum frequency can be in the range of the 10 kilohertz. And of course, there is no harm in push pull converter operating for this 250 watt, and you can choose a switching frequency of 100 kilohertz. So, generally we do not do that. So, we have this kind of breakup because this is the simplest circuit and gradually the number of switches get increased, because this solution is a one switch solutions. This solution is also one switch solutions, but magnetics will be higher. We shall see that actually we should have a higher magnetic component here. Push pull is essentially the two switch solution, and half bridge is also a two switch solutions, and thereafter full bridge is a four switch solution. Now, there are few issues involved of the DC to DC converter, since in between you have a transformer. So, if you once you are basically chopping this, and thus actually current will flow from this to this. In case of the normal transformer operation, flyback will be a different, will come later. So, what will happen, you will be, when you are chopping, if you have this kind of voltages and you are applying to the, this is the voltage, and you are applying the same to the transformer. So, then what will happen? What will happen to the flux? This is the integration of this voltage. So, it will ramp on till this point, thereafter it will be like this, thereafter on this point and so on, it will go up, and after some point of time actually you will reach the phi m. So, ultimately this transformer will be saturating, no voltage will be linked to the secondary. So, one of the requirement of this all magnetic space solution, you require to reset the flux in every cycle, and you have to apply some way positive voltage, then in some way you will reset it to the negative voltage, so that actually residual flux in this transformer becomes 0. This is the challenge here of this all these DC to DC converter. We will see that, and due to that switch will have a high voltage stress. So, you want to have this kind of voltage applied, then you have to then you cannot continue to apply negative voltage for the same duration of the time. What you essentially you do a higher voltage, and you try to reset this voltage, this flux and this flux, this integration of this time voltage curve. And then what happen? The stress across the switch becomes higher, and it should have also the reverse blocking capability. So, this is the one of the challenge. You will see that how you reset the flux. Sooner you try to reset the flux, then it will give you a higher stress across the switching. Anyway, we have another 3-4 drawbacks of the SMPS, and we have to address it, and we will find it out how it can be done. For this reason, design of this actually isolated DC to DC converter little challenging. Thank you so much for your attention. Thank you.